Hey guys, welcome back to the channel. In this video, I'll be covering the vertical line test and how we apply it and why it is a little bit important to calculus. So let's just hop right into it. In a previous video, I mentioned the vertical line test and in the definition of functions. Well, what is it? Alright, so it's a test to determine if f of x is a function. Is f a function? Move that over, guys. Sorry about that. So essentially, let's say we're just given a curve, okay? So let's say we're given a graph, okay? For now, for simplicity, we're going to start with a straight line. So essentially, the vertical line test states if it intersects, so pretty much if there's only, so if we draw a invisible vertical line through every point on the x, if it only touches one value of x, meaning there's only one input for every, there's one unique output for every input, is a function. So in this case, this is a function. The line as you see here, we're drawing vertical lines through the function. Sorry, it's not perfect. I would be using graph paper actually. That's the easiest way to show it, but it is what we have. But since we take a vertical line and it goes through only one point along the x, so there's only one y point for every x point, it passes the vertical line test, so it is a function. Move that over a little bit for you guys. Okay, so pretty much the vertical line test states if a vertical line passes through only one point on the graph of f, then f is a function. Okay. Now, you guys are saying, okay, I get that. All right, but how's that come about? All right. So if you guys remember back in the introduction to functions, we defined a function as an input. So let's just draw a little machine. All right, so we have x. So we put in any x, it spits out f of x. Okay. If you guys remember. So meaning if we draw a t-chart, we have, say, 0, 1, 2, and 3. It has one input. One unique input gives us a unique output. So 1x, there's a y. So 3, 2, 1, 4. Different outputs. Now, question for you guys. Is this a function? Okay. Go ahead, feel free to pause it if you guys feel like you guys need to. Alright, so say we have the graph of x squared. Is this a function? Alright, so this is 2, 2. Say this is 2, 2. And say this is negative 2, 2. Well, is this a function? Alright, hopefully you guys pause it to think about it for a second. But, alright, let's think about it. So if we draw a vertical line, like, again, going through all the points along the x, so on and so forth, it does. It only intersects one point. So meaning different outputs could have this. So there could be multiple outputs, multiple of the same outputs for the same for different numbers, but no two output numbers for one input number. Could be a thing. It could exist for it to be a for f to be a function. So this is a function. All right, and the easiest way to demonstrate that is with a vertical line, a horizontal line. So drawing a set of axes through point C. Every point has Every point so every input for this graph has an input of C, has an output of C for every input, and vertical lines do go straight through. Okay, question. All right. So vertical lines do go through each and every single point, only touching one x point, only touching one point for every value of x. So it is a function. What if? All right. So question for you guys is so we say we're given something like this. Say a vertical line. Is that a function? All right. So we try to take a vertical line. Sorry, guys. We try to take a vertical line, but it intersects multiple points. So this is not a function. All right. So it intersects not a function, and the reason why is because it intersects multiple points for one value. Say call this C or call this A. Sorry. So there's multiple values for the input value of A. Okay, you got that. Okay, so I'll give you another another example, right? So say we have a sideways parabola. You guys will see this a lot when you guys so you guys see this quite a bit later on in math. A sideways parabola. Is this a function? Some people, so you don't be too quick to judge it. It is not a function. All right, take a vertical line. Once again, draw invisible vertical lines. And as you see here, it intersects here. Sorry about that, guys. Sorry for the cut in the video. We were last talking about functions, the vertical line test. So in this example, we take a vertical line, this sideways parabola, and we take vertical lines straight through. As you see here, it touches through 2 points. Therefore, it's not a function at all. It can't be a function because it fails at the vertical line test. All right. Another example of this is a circle. A circle through the origin touches at 2 points. It fails. Not a function. All right, so just to recap, pretty much for every so in a previous video we defined a function as one unique input output for every input, meaning only one y for every x, or every f of x for one x. All right, so only one y for one y, one f of x for one x, and so. If we're given a graph, we could apply the vertical line test to test if a function is a function, and we do that by taking invisible vertical lines to really test to see if there's only one point that's intersected. If it intersects only one point for all values of x, f is a function. If it does not, so if it intersects 2 or more, it's not a function. It's a relation, not a function. Like a vertical line, or not a vertical line, a straight line going through the origin is an example. A horizontal line is an example. A parabola. So those are degrees of polynomials, which we'll cover in a future video. Are all examples of functions. Whereas if we take a vertical line, a straight vertical line, a sideways parabola, a circle, anything, those intersect at multiple points, making it not a function. I'll see you guys next video.